Earth, a planet defined by life.
The amazing thing about life here on Earth is no matter where you look, you'll find it.
But is Earth unique?
The big question of our day is, does life exist somewhere else beside the Earth?
Are we that special, or is life everywhere?
The ingredients for life are spread throughout the universe.
But then we started looking into space and saying, wait a second, that chemistry is everywhere.
Is life inevitable?
I think that there have to be planets out there that are capable of hosting life.
What does life need to get started? And once started, can life spread?
It's possible that life started on Mars and was transferred to Earth inside of a meteorite.
Life has conquered our planet, but can life conquer the universe? The universe is a very big place. There are trillions of galaxies, each one home to millions of stars and an unimaginable number of planets. So, where is everybody?
One of the most basic philosophical questions is, are we alone?
Are we the only ones looking out and thinking, what is all this?
Is it all just for us? Or do we get to share it with anyone?
I mean, that's about as fundamental a question as you get.
What are the odds of life existing somewhere else?
We just don't have a good insight to how probable life is anywhere in the universe.
Life could possibly be forming everywhere. We don't quite know. There's a lot about life that we don't understand.
All we know is that it happened at least once.
But beyond this one little planet, we don't know whether or not it happened anywhere else.
The universe is an unfriendly place. Planets with lava oceans circle too close to their stars. Pulsars blaze with deadly gamma rays and X-rays. Black holes consume everything in their path. Temperatures plummet close to absolute zero. It may seem impossible for life to survive in such hostile environments. But here on Earth, life exists against the odds in some very strange places.
Life has actually permeated every part of our planet. There are places where you're like, how did you even get there?
At first glance, a beautiful lake might seem like a good place for life. But California's Salton Sea is no paradise. The toxic salt waters are a killer. Surrounded by scorched desert and volcanic geothermal fields. It's a deadly environment. One of the last places on Earth you'd expect to find life would be in boiling mud vents.
You can start to hear these vents because there's gas and there's water and mud slurry that's coming out right here. So these are active mud volcanoes. It's really hot. It's like 164 degrees Fahrenheit.
But life is resilient, finding a home even here, inside volcanic vents in the California desert.
We're in the middle of a really hot desert, and as the mud comes up, it's coming up hot and it's kind of acid, and yet there can be microbes in environments like this happily thriving away. This is an environment that is actually conducive to life, even though we think it might not be.
Almost every inch of the Earth's surface is teeming with microscopic life forms.
The thing about life on Earth is that it exists in so many different environments under such harsh and extreme conditions. It's like it hangs on no matter what you throw at it.
very dry, high pressure, very hot, even in high radiation environments, which would kill a human within seconds.
Life even survives being bombed with asteroids and meteorites.
We have a wonderful indirect example of just how tenacious life is, and that's the fact that it survived the late heavy bombardment.
The late heavy bombardment was a violent assault on young Earth, where life had just gotten a foothold. Experts think around 4 billion years ago, asteroids, comets, and space debris rained down on the inner solar system. This rocky barrage would have melted parts of the Earth's crust and boiled away oceans. It was a violent time called the Hadean period.
The Hadean, named after Hades, named after the underworld, after hell. It was a brutally unpleasant place to be. It was spewing its own innards out onto the surface in this intense cycle of hot volcanism.
If life on Earth overcame these hellish conditions, then perhaps life can survive anywhere.
I think if it can happen on Earth, I think it can happen on other planets. I think life finds a way, and I think we need to go looking for it.
The question is, what exactly are we looking for?
What is life? That seems like a simple question, but it's not that easy to answer.
Life is incredibly hard to define, right? It's sort of like you know it when you see it, but how do you write down the rules?
Every time we think we have a grasp, there's this new form that comes about and completely questions that entire definition.
There's a joke in astrobiology that if you ask 200 scientists for a definition of life, you'll get 200 different answers.
Life can be as intricate as us humans, or as simple as single-celled organisms, like bacteria. But there are some things all life forms do.
In broad terms, life consumes things. It breathes, it eats, it excretes, it grows, it reproduces, it's complex.
Life has transformed the Earth in all sorts of ways. But life is still just an accident.
Life, as I see it, is just a chemical reaction, but it's the most important and special chemical reaction in the universe.
If life is just a product of chemistry, then what are the odds of it starting anywhere in the universe?
One thing we know about chemistry is that given the right conditions, the same chemical reaction will reliably occur.
It's like a game of chance. For life to win, the conditions need to be just right. But to figure out the odds, we need to understand what those conditions are and how common they are.
So it comes down to a numbers game. It's about statistics and probabilities and likelihood.
It's like having to roll a 6 for each condition for life. But how many 6s would you need? How many precise conditions does life require to get going?
You might have 100 dice. Roll them all, get all 6s, only then do you get life.
You could need hundreds or hundreds of thousands of dice. We just don't know.
We honestly have no clue how common or rare life is in the universe.
We don't know how life originated here on Earth, where we kind of understand the conditions. There are a lot of different ways life could have started.
Is life rare? Is life common? We don't know where it lands.
Putting odds on life existing is a waste of time until we understand it better. And maybe our answers don't lie here on Earth.
One way to crack this problem is to go looking for life elsewhere. If we can find other examples of life, we can immediately begin to put a quantitative answer to how probable it is for life to happen anywhere.
And the best place to look for life might be in our own backyard. Mars. If life can start here, then maybe life could conquer the universe. For life to conquer the universe, first, it has to get going.
When we look at life on Earth, it's possible that it all has a common ancestor. Life started at one spot, branched out, and became all the different kinds of life that we see.
But how did it start? The first question to answer is, what is life made of? Top of the list are the most basic building blocks, chemical elements.
Here's what I know about the universe. The laws of physics appear to be the same everywhere. The chemical composition, the elements, are the same everywhere.
And the cosmos creates these elements not from the Big Bang, but from stars.
Over the course of a star's life, it creates elements. And when a star dies, these elements are blasted out into space in a supernova, spreading the ingredients for life out into the cosmos.
We, the Earth, our solar system, all the ingredients that make us us were forged in nuclear fires. So the death of stars leads to the birth of life.
Those key ingredients include oxygen, nitrogen, sulfur, and phosphorus. But the element most central to life as we know it is carbon.
All life as we know it on Earth is based on carbon.
Carbon forms the structure, the architecture of our living molecules.
Carbon is an incredibly versatile building material. It can bond with other elements to form long-chain molecules, each with different properties.
As an element, it seems to be capable of producing a vast and complex chemistry. And that complex chemistry is what we find in life.
We call this organic chemistry. But getting from basic organic molecules to complex life forms is a big leap.
We don't really have the slightest idea, to be honest, about how life on Earth got started.
A really big question is how you go from a mix of relatively simple organic molecules to a living system.
We know it all starts with basic elements, created in massive quantities by the death of stars.
But how do you start connecting those Lego bricks together to build that first cell?
The short answer is we don't know. But we have some ideas of potential steps.
Chains of organic molecules become more and more complex. Amino acids form proteins. Fatty acids form phospholipids, which make cell membranes. Nucleic acids form DNA, the molecule that stores genetic information. Eventually, a simple cell emerges.
All of the bits you need to plug together to build a cell from scratch seems to exist in outer space.
We found organic compounds everywhere. They're all over the place. Planets, comets, gas clouds.
The very basic ingredients of life available elsewhere in our solar system. So there could be life everywhere.
In 2018, NASA announces it's found organic molecules on another planet. A planet we've always suspected of harboring alien life. Mars.
So whenever NASA has a press conference and they say they have some important results to report on about Mars, everyone goes nuts.
The internet goes mad. Maybe we've got photographic evidence of little green men in a UFO.
This time, it's the Martians. They're gonna tell us they found the Martians.
The world listens because everyone wants to know. Everyone asks the question, have we found evidence of life?
For 6 years, the Mars Curiosity rover has been exploring a region called Gale Crater, hunting for signs of ancient life. A bit like fossil hunting on Earth.
Gale Crater is not unlike places on Earth that can preserve fossils. So a really good example of this would be the petrified forest in Arizona. This looks like a piece of wood, but in fact, it is stone. It is all stone. But it used to be a tree. This fossil lived 200 million years ago.
This patch of desert in Arizona once looked completely different.
This landscape looks very dry right now, but 200 million years ago, it was wet swampland with trees and flowing water.
Like the petrified forest, Mars has also changed over time. Gale Crater was once a lake bed filled with fresh water.
And it was just so exciting because we knew then that we had landed right on top of an environment that once had tons of flowing water and could very well have preserved organic materials, even though it looks very barren and desolate to our eyes.
In 2018, Curiosity drills into this ancient Martian lake and discovers organic molecules.
Finding organics on Mars is so exciting just because, wow, those are the building blocks of life, not just the elements, but actual molecules.
There was a wave of excitement after the announcement of organics found on Mars and complex organics. It's not totally indicative that life is there, but it's a really good telltale sign that there may be possibly life forms on Mars.
The results aren't proof of Martians, but the ancient lake bed is evidence that the red planet once had something else crucial for life: liquid water.
It's one thing if you have all these ingredients lying around for life. You could have, carbon over here and hydrogen over here, or maybe methane or whatever. But you have to mix them together. So you need something for them to be in, a medium of some sort.
Life needs a liquid to mix essential chemicals together. We're used to thinking of Earth as the only water world in our solar system. But new evidence says otherwise. As extraterrestrial visitors carrying liquid water from outer space reveal. It's no coincidence our blue planet is a water world. There are more than 366 million trillion gallons of water on Earth. It even makes up 60% of our bodies.
I think life on Earth could be easily described as water chemistry. That is the essential feature of life on Earth.
Some is locked up in ice caps or as vapor in the air. But 96% of liquid water is in our oceans.
Well, Earth is really special. There's no other place like it that we found. It's a pretty substantial planet with liquid water covering 70% of the surface.
All life on the Earth requires bodies of water in order to survive. No water, no life.
Water is what chemists call a solvent. And it's the best solvent we know of. It can dissolve more substances than any other liquid, allowing molecules to mix and interact. Wherever water goes, it transports valuable chemicals, minerals, and nutrients.
If there was no liquid, things would just sit around separately. You need this constant interaction, and you need a different chemical mix, and water does all of that.
And so a lot of our searches for life-like planets or Earth-like planets outside our solar system are based on this sort of primary assumption that we need liquid water.
We've long thought Earth has liquid water because of its unique position in the solar system.
It's right in this zone that we call the habitable zone, where the sunlight can support liquid water on the surface of the planet.
But we have now discovered that liquid water might exist in places we never expected. In 1998, a meteorite crash lands in Texas. Today, scientists at Arizona State University are still studying its secrets.
We had no idea that it would contain this really, really spectacular finding.
It contains a mysterious purple mineral. The exotic color comes from exposure to cosmic radiation, but the compound itself is very ordinary.
It's actually sodium chloride, which is essentially the same mineral as table salt. But what's really cool is that it actually contains little globules of liquid water. And that liquid water was trapped in these crystals 4.5 billion years ago.
In 2018, scientists re-examined the crystals and discovered the liquid water wasn't traveling alone.
We've now actually found organic compounds in association with this liquid water in these salt crystals. And that's something that's really new and really spectacular.
We actually found amino acids, the building blocks of all of our proteins, even our DNA, and we found liquid water, the very building blocks of life, inside a meteorite.
So, could life exist somewhere else in our solar system? A NASA mission to Saturn turned up some shocking results. The Cassini space probe flew beneath Saturn's moon, Enceladus.
Enceladus, no one cared about. It was a tiny little snowball of a world.
But Enceladus surprised everyone. Geysers of liquid water, dozens of them, blast out of trenches along the moon's surface, coming from a vast subsurface ocean. Oceans on Earth are full of life. Could the same be true of Enceladus?
I'm a big fan of Enceladus. I think it's by far and away the best place to go to search for evidence of life.
In 2018, researchers analyzing the Cassini data discovered that the plumes of Enceladus contain complex organic molecules.
Just simple molecules, we find those, like methane. But the Cassini results are showing that there are these more complex, larger organic molecules as well.
This is the first ever detection of complex organics on an extraterrestrial water world.
All of a sudden, here's water jetting out, carrying organic material, all the ingredients needed for life. It was like too good to be true.
But Enceladus isn't the only small world with a subsurface ocean. Other moons and dwarf planets have liquid water too.
We think the most important thing for life to form is the presence of liquid water, and our solar system seems to be full of it.
The discovery of liquid water in the outer solar system changes the rules of how life might originate in the universe.
Across the universe, alien life could be hiding underneath the surface.
Internal water oceans are far more common than surface water oceans. So if there is a lot of life out there in the universe, chances are it's in an internal ocean under miles of ice.
Who knows what might be lurking inside icy exoworlds?
There may be jellyfish and octopuses all over the place in exomoons and exoplanets under ice that have civilizations that we just don't know about.
Finding liquid water oceans could open up a world of possibilities.
If you're not excited about intelligent extraterrestrial octopus civilizations, I don't know what to say.
The chances of finding life in our solar system just got a heck of a lot better. Building blocks and liquid water are common. But you need more than just these two conditions for life to take hold. Life needs a spark.
Life appears to need some form of energy to actually get the molecules interacting.
One thing that may have helped kickstart life on Earth is ultraviolet radiation from the sun.
Ultraviolet light is emitted by all stars. There are billions of stars in our galaxy. Can life get started around any star? Or is our sun unique? Earth is a solar-powered planet. At the bottom of the food chain, plants use photosynthesis to convert sunlight into chemical energy. Food for the rest of us.
I like eating both grass, essentially wheat, and I also fancy the odd hamburger from a cow that is eating that grass. So this whole ecosystem is powered by sunshine.
But recent studies have shed new light on how life developed under our sun. Specifically, the role of ultraviolet light.
UV radiation is useful for breaking molecules up and triggering reactions. Maybe that played a role in the origin of life.
It breaks down simple organic molecules, and then they can rebuild themselves into things that are more complex. If you do that over and over again, eventually you somehow get life.
Scientists think life on Earth started around 4 billion years ago. A time when Earth's atmosphere gave little protection. UV radiation levels were 100 times higher. Was UV essential for the development of life's code, DNA?
We know that life on Earth stores information in DNA and then uses that information to build proteins. So we have the blueprints and the bricks. The blueprints are the DNA and the bricks are the proteins.
But we think that the first life on Earth, we used a chemical which is much simpler.
This simpler chemical was RNA, DNA's single-stranded forefather.
RNA is almost like a 2-for-1 offer. It does both of the fundamental things you need for a cell in the same compound.
So it was simultaneously the bricks and the blueprint.
Unlike other molecules, RNA is more resistant to the high UV environment of early Earth, allowing it to flourish. RNA eventually evolved into DNA, and life started.
To have life on the planet, one important consideration is a certain amount of light that's going to be needed, and a certain type of light that's going to be needed.
So if all stars emit some UV radiation, can life start around any star?
When we think about looking for places that are conducive for life, we want to find a planet that might have enough UV radiation, so the star is bright enough or close enough that it's providing enough energy to the surface for life, but we also don't want to have too much UV radiation.
It seems you need just the right amount of UV. The most common stars in the galaxy are red dwarf stars.
If red dwarf stars can harbor life on planets around them, there's an awful lot of real estate like that in our galaxy.
Red dwarf stars could be good for life's chance of conquering the universe in a number of ways.
One, they represent over 3/4 of all stars in the universe. 2, they live for over 1,000 times longer than sun-like stars. And 3, they seem to have rocky planets around them much more often than sun-like stars do.
Those are the pros, but red dwarf stars also have cons. For instance, they might not be bright enough for life to begin.
Some of the red dwarf stars that we know emit less ultraviolet light than the sun.
They don't give off much UV light at all. Maybe on a planet around them, there isn't enough energy to get life started.
Red dwarf stars are also much more temperamental. They can go from being gentle and quiet to having violent outbursts. Stellar flares.
These types of stars have incredibly strong flares. That means they're shooting off a bunch of energetic particles and radiation and light that's baking the surfaces of those planets.
If the star is just bombarding the surface with UV, then it will destroy all of those things necessary for life. It will actually destroy the life itself.
These stellar flares could strip away a planet's atmosphere, sterilizing the surface. More research is needed, but for now, the odds of life thriving around dwarf stars are a toss-up. So far, the only thing we know is that there is one kind of star that's definitely right for life: our sun.
We know of life in one place in the universe, and that's here, that's Earth.
Only 4% of stars in the universe are like our sun. So, if life can only get started around these rare, medium-sized stars, the chances are not looking good. But life may have an ace up its sleeve. What if life can start on just one planet and then spread? What if life travels across the cosmos looking for planets to conquer? Earth is our only example of life emerging anywhere in the universe. But what if life on Earth didn't start on Earth at all?
There's one idea that life on Earth actually didn't get going here, but was delivered from space.
Scientists call this theory panspermia.
The idea of panspermia essentially talks about the transferal of life throughout the cosmos.
We know asteroids and comets carry organic molecules. But could they carry life itself?
What if life starts on one planet? Can it actually get itself to a nearby planet? Is it possible that meteorites could actually transport living beings?
For life to travel around the cosmos, first it needs to take flight. An asteroid is on a collision course with an inhabited planet.
So what happens if there's a huge cataclysmic collision on a planet? Material is blasted off into space.
The impact might kill life on the surface of that planet. But it's possible some bacteria might escape, hitching a ride on chunks of the planet's surface.
A meteorite being ejected from a planet after an asteroid impact, I mean, that's not going to be an easy ride. But it turns out it's not as bad as you think.
Some bacteria are very, very hard to kill. Some we even don't know how to kill. Even the impact that actually threw that rock into space, for bacteria, no problem.
If those chunks of rock expelled during asteroid collisions could actually hold on to viable organisms, then it really could change the way in which we think about life spreading in the universe.
If the microbes can survive takeoff, then they can start their journey to a new home. The odds of life conquering the universe seem to be getting better.
The important question now is, how long could that life, those bacteria, those microorganisms inside that rock, survive the space environment?
Exposure to UV radiation could be fatal, killing any life on the surface of an asteroid. But experts think that microbial passengers could still survive by hiding underground.
It doesn't take much to shield a microorganism from UV. Just a little bit of rock and you have enough protection to just hold on throughout a journey to the next body, to your next home.
Eventually, they could arrive at an uninhabited world that's ready and waiting for life. But they're in for a bumpy landing. Would the rock burn up coming through a planet's atmosphere?
It's in for a hot ride, but only for a few seconds. and only the outer layers of that rock will blow off. And then it just falls and hits the ground not that fast, a couple 100 miles an hour. If a human were in there, that would be bad, but for a bacterium, no big deal.
The panspermia theory says life could start on just one planet, then spread to another planet, and possibly another. If we found alien life forms, would they look familiar?
One of the biggest questions about finding other life in the solar system is how similar will it be to us? If it's just like us, it begs the question, did we have a common genesis? Did we originally come from another planet?
One radical idea is that life on Earth came from Mars.
Imagine Mars 3.5, 4 billion years ago. It was more Earth-like then than Earth was at that point. The Earth was still quite warm. Mars actually had cooled off faster, had a thick atmosphere, water. Life could have arisen there.
Mars has been hit repeatedly by meteors, sending chunks of the planet flying off into space. And some of those chunks have landed here on Earth.
So this is a really unusual meteorite. It was found near the city of Los Angeles, and we actually know that it actually came from the planet Mars, and we know that because it has gases trapped inside it that have the exact same composition as a Martian atmosphere.
There's been a lot of transit between meteor strikes hitting Mars and on Earth. There's a little bit of Mars on Earth, there's a little bit of Earth on Mars.
It's possible that life started on Mars and was transferred to Earth inside of a meteorite.
When you think about it, maybe we're the immigrants. We are the Martians. Life on Earth started on Mars and got transferred here.
Panspermia could allow life to spread from planet to planet, conquering our solar system. But what about even greater distances? In 2017, the cigar-shaped space rock, Oumuamua, appeared in our solar system. It came from interstellar space, and experts think it could be carrying organic matter.
One of the fascinating things about Oumuamua is it has sort of a reddened surface. Now, that could actually partially be from the presence of organic molecules.
Could life survive interstellar or even intergalactic travel?
Whether or not this is an easy way to transfer life around in the universe is still an open question. The possibility of transferring life from star system to star system seems a little bit remote.
The immense distances and dangers of interstellar travel would be hard to survive. Some experts think there is one way for life to conquer the universe. But it won't be life as we know it. The universe is unimaginably large. Many experts believe there is life out there. We just have to go find it.
One of the things I love about being a human is the fact that I'm born with this curiosity. This curiosity drives us to explore Earth, explore our solar system, and beyond, into the galaxy, look for other life forms.
But with current technology, it would take thousands of years just to reach the nearest star. It's unlikely humans will ever leave our galaxy.
If life one day does spread from Earth into the cosmos, it's probably not just going to be a bunch of meat bags like us, but other forms of life that are more suited for interstellar and intergalactic travel.
Our fragile bodies are not suited to the distances and dangers of interstellar travel.
Machine life may be more robust for traveling between planets and between stars than biological life.
There are a lot of scientists who think that when we encounter aliens, we won't be encountering them, we'll be encountering their machines, because we can build machines that can last 1 million years, go from one star to the next. It's much easier than transporting us fragile, gloppy bags of meat. And so if we go out into space, we're more likely to find robots than we are biological life.
For humanity to discover alien life, humanity itself may have to evolve. From biological life to artificial life.
What's really ironic here is that while we're figuring out the origin of life on Earth, we humans could be inventing a form of life on our own. And that is what we call artificial intelligence.
The development of AI, self-replicating machines even, may very well be just the next key transition in our evolutionary history.
Could a super-intelligent, self-replicating machine conquer the universe?
Maybe this AI can fashion its own machines, create factories to create resources to replicate itself, create ships that will allow it to travel from one place in the universe to another.
But would AI represent a new form of life?
I think the answer is yes, and I think it actually goes on from there. I think artificial intelligence might be the next necessary stage in evolution. We made the computers. They are our children.
I think of life as a process that can retain its complexity and reproduce. So, bacteria are life, humans are life, and some future creation of advanced artificial intelligence that can do those things should also count as life.
Life could take many forms, and in such a vast universe, it could be that life is inevitable.
With all those stars and all those planets, I think without a doubt, there is a good chance that life has developed elsewhere in our universe.
Must life happen in our universe? Is it an inevitable consequence of processes in operation? Maybe, maybe not.
Until we find it, we won't know for sure whether life can conquer the universe.